Hello. So in this video, our topic is all about an operating system, and we're gonna discuss what about in the interfacing of it. So now we're gonna talk about what are components of the computer system. So here we're gonna talk about this compiler, assembler, text editor, and the database system. So what is compiler? A compiler is computer's software that translates or compiles source code written in a high-level language, for example, the C++, into a set of machine language instructions that can be understood by a digital computer CPU. Compilers are very large programs with error checking and other abilities. Some compilers translate high-level language into an intermediate assembly language, which is then translated or assembled in a machine code by an assembly program or assembler. Other compilers generate machine language directly, so the term compiler was coined by the American computer scientist or she known as Grace Hopper, who designed one of the first compilers in the early 1950s. A compiler is a software that converts the source code to the object code. In other words, we can say that it converts the high-level language to machine or the binary language. Moreover, it is necessary to perform this step to make the program executable. So this because the computer understands only binary language. Some compilers convert the high-level language to an assembly language as an intermediate step, whereas some others convert it indirect to machine code. So this process of converting the source code into machine code is called the compilation. So now let us learn more about it in detail. So here, did you know there are four types of compiler? We have the cross compilers that they produce an executable machine code for a platform, but this platform is not the one on which the compiler is running. So as you can see, the bootstrap compilers. So we can see this into programming like that. So these compilers are written in a programming language that they have to compile. So as you can see, if we program or we program code, so this bootstrap compilers is in there. So the third, we have the source to source or the transcompiler. So these compilers convert the source code of one programming language to the source code of another program language. So the next, we have the decompiler. Basically, it is not a compiler. It is just the reverse of the compiler. It converts the machine code into high-level language. So now, what is assembler? Assembler is a type of computer program that interprets software programs written in assembly language into machine language, code and instructions that can be executed by a computer. An assembler enables software and applications developers to access, operate, and manage a computer's hardware, architecture, and components. An assembler is sometimes referred to as the compiler of assembly language, and it also provides the services of an interpreter. Assemblers are classified based on the number of times it takes them to read the source code before translating it. There are both single-pass and multi-pass assemblers. Moreover, some high-end assemblers provide enhanced functionality by enabling the use of control statements, data abstraction services, and providing support for object-oriented programming structures. So now, what is text editor? A text editor is a tool that allows a user to create and revise documents in a computer. Though this task can be carried out in other modes, the word text editor commonly refers to the tool that does this interactively. Earlier computer documents used to be primarily plain text documents. But nowadays, due to improved input-output mechanisms, In file formats, a document frequently contains a pictures along with texts whose appearance or the script size, the color, and style can be varied within the document. Apart from producing output of such wide variety, text editors today provide many advanced features of interactiveness and output. So here, the type of editors. So here, depending on how editing is performed and the type of output that can be generated, or the editors can be broadly classified as the line editors, the stream editors, word processors, or screen editors, or structures editors. So now, we're going to talk about the line editors. So during original creations, lines of text are recognized and delimited by end-of-line markers, and during subsequent revisions, the line must be explicitly specified by line number or by some further context. Example, the idling or editor in early MS or DOS system. And the next we have stream editors. So the idea here is similar to line editor, but the entire text is treated as single stream of characters. Hence, the locations for revisions cannot be specified using line numbers. Locations for revisions are either specified by explicit positioning or by using pattern context. For example, the in Unix or the Linux. The word processors. It provides additional features to basic screen editors, usually supports non-textual contents and choice of font style or etc. And screen editors, these allow the document to be viewed and operated upon as a two-dimensional plane of which a portions may be displayed at a time. Any portions may be specified for display, and location for revisions can be specified anywhere within the displayed portion. For example, the VI, the Rmax, and etc. Structures editors. These are editors for specific types of documents so that the editors recognizes the structures or the syntax of the document being prepared and helps in maintaining that structures or the syntax. So now we'll jump here into the databases, but firstly, before we learn about the database, let us understand what is data. So here, in simple words, data can be fact related to any object in considerations, for example, your name, age, your height, and your weight, or etc. So are some data related to you or a picture, the images or the file, PDF, or etc. can also be called considered as data. So here, what is a database? A database is a systematic collection of data. They support electronic storage and manipulations of data. Databases make data management easy. Let us discuss a database example. An online telephone directory uses a database to store data of people, the phone numbers, and the other contact details. So your electricity services provider uses a database to manage billing. So now here, client related issues, handled fault data, or etc. Let us also consider the Facebook. It needs to store, manipulate, and presenting data related to the members, their friends, the member activities, the messages, the advertisements, and a lot more on Facebook. So we can provide a countless number of examples of the uses of the database. So the next we have the types of databases. So firstly, the distributed databases. The distributed database is a type of database that has contributions from the common database and information captured by local and computers. In this type of database system, the data is not in one place and it's distributed at various organizations. And next we have the relational database. This type of database defines database relationships in the form of the table. It is also called the relational DBMS, which is the most popular DBMS type in the market. Database example of the RDBMS systems include MySQL, the Oracle, and the Microsoft SQL Server database. And the next we have object-oriented databases. These types of computers database supports the storage of all data types. So the data is stored in the form of objects. The objects to be held in the database have attributes and methods that define what to do with the data. Or the PostgreSQL is an example of object-oriented relational DBMS. The centralized databases. It is a centralized location and users from different backgrounds can access this data. This type of computers databases stored applications, procedures that help users access the data even from remote locations. And the next we have operation source databases. This kind of database is stored in informations related to operations. It is mainly used in the field of marketing, employees relations, customer services of databases. Cloud database. A cloud database is a database which is optimized or built for such as virtualized environment. There are so many advantages of cloud database, some of which can pay for storage capacity and bandwidth. It also offers scalability on demand along with high availability. Network DBMS. This type of DBMS supports many-to-many relations. It is usually results in complex database structures. RDM server is an example of database management system that implements the network model. So here the database components. As you can see, if you see the hardware, so if you use this hardware, you use software. And if you use software, you use data. And if you use the data, it processed here and it used in a data access language. So here, the components of this database. And the next here is the principle of cache memory. The cache memory typically consists of high-speed memory, associative memory, replacement logic circuitry, and corresponding control circuitry. In a computer system with a cache, the address of central processor accessing the main memory is divided into three fields: a row number, a column number, and an intra-group address. Thus, the main memory is logically divided into rows. Each row is divided into a number of memory cell groups. Each group contains several or tens of words. The high-speed memory is also divided into rows and columns of memory cell groups accordingly. The number of columns is the same, the size of the group is the same, but the number of lines in the high-speed memory is less than the number of lines in the main memory. So, associative memory is used for address association and has the same number of rows and columns as the high-speed memory. When a certain row of memory cell in a column of the main memory is transferred to an empty memory cell group in the same column of the high-speed memory, the memory cell corresponding to the associative memory records the row numbers of the loaded memory cell group in the main memory. So, the role of cache memory and the development of the computer technology. The main memory access speed has been much slower than that of the central processing unit, so that the high-speed processing capability of the central processing unit cannot be fully utilized, and the working efficiency of the entire computer system is affected. So there are many ways to mitigate the speed or mismatch between the central processor and the main memory. So for example, using multiple general purpose registers. multi-bank interleaving, etc. It is also a common method to use the cache at the storage level. Many large and medium-sized computers, as well as some recent mini computers and mini computers, also use cache memories. The size of cache is typically only a few hundredths of that of main memory. So, but its access speed matches the central processor. So, according to the principle of program locality, it is highly probable that those units in the vicinity of a unit of the main memory being used will be used. Thus, when the central processor accesses a unit of the main memory, the computer hardware automatically transfers the set of unit contents, including the unit, into the cache memory. In the main memory, unit to be accessed by the central processing unit is likely just in the set of cells that have just been loaded into the cache. Thus, the central processor can directly access the cache. Throughout the process, if most of the central processor's access to the main memory can be replaced by access to the cache, the processing speed of the computer system can be significantly improved. So now this is the cache memory. So as you can see right here, we can see the CPU, the cache, and the memory. So if you transfer the data into CPU to cache, so they called it word transfer, and if the cache to main memory, it's called a block transfer. So as you can see the arrow, connect into cache and cache to main memory and memory to cache and cache to CPU. So this is the flow of this cache memory. So there are some questions about in this cache memory. So now, what is a cache memory? So what it is used? Cache memory, also called cache, a supplementary memory system that temporarily stores frequently used instructions and data for quicker processing by the central processing unit or the CPU of computer. So the cache augments and is an extension of a computer's main memory. So now, what are the three types of cache memory? So here there are three types of cache. Direct map cache, fully associative cache, and reset associative cache. When should you use cache memory? Data architecture requires data caching because having data stored locally in memory can help reduce issues such as long latency times between requests and high concurrency of users in memory. Caching can also help reduce runtimes of requests and batch jobs. And what is the main purpose of the cache memory? So the purpose of cache memory is to store program instructions that are frequently used by the software during its general operation. This is why fast access is needed, as it helps to keep the program running quickly. So what is cache memory with example? So the memory cache, so this is the here, so when an application is running, it may cache certain data in the system memory or the RAM. So for example, if you are working on a video project, the video editor may load specific video clips and audio tracks from the hard drive into RAM. Processor caches are even smaller than these caches. So now we're gonna talk about the process state. So as you can see, as a process executes its change state, the state of process is defined in part by the current activity of the process. So each of process may be in one of the following states. So here in the process state, we have the new as a process executes its change state here. And the next we have the running. So the running is its instructions are being executed. And in a waiting is the process waiting for some event to occur, such as an I/O computations or reception of a signal. And also in the ready, so as you can see that we know that the ready is process, it processes the waiting to be assigned to a processor. And the next is the terminated. So this process has finished execution or executed. So now this is the flow of this process state. As you can see, for example, we get a data here, we create a new data, and the data is stored here, will be stored here. And that data, it process and admitted, and that data will be going to, we use it, we're ready to use it, so we'll be going here, it transferred here, and after that data, this data process until this data ready to run, and until this data running. So if this data has a problem, so this data interrupt, or so you interrupt this, or you terminate this data because there's a problem. So here we'll be going here and terminate, and that end of this data. So if that data is running, or that data is loaded at very loaded, so in that cases, there are many cases that there are many data interrupted. So this data interrupted will be going here, interrupt, and will be back here and preferred to another uh, kind of operations or something like process. So after the data ready, it running here or schedule is dispatch here. So while this data running, if this data is successfully, we're going here and stored here. So this data waiting until this the user uh, send here, and until if this ready, and until this data it terminated or executed. So now we talk about the process threads, or in a computer science, a thread of execution is the smallest sequence of program instructions that can be managed independently by a scheduler, which is typically a part of the operating system. The implementation of threads and processes differs between operating system, but in most cases, a thread is a component of process. Multiple threads can exist within one process, executing concurrently, and sharing resources such as memory, while different processes do not share these resources. In particularly, the threads of process shared its executable code and the values of its dynamically allocated variables and non-thread local global variables at any given time. So here, what is the process? The process means any program is in executions. So the process control block controls the operations of any process. The process control block contains information about processes, for example, process priority, process ID, process state, the CPU, the register, or etc. A process can create other processes which are known as child process. Process takes more time to terminate, and it's isolated, mean it does not share memory with any other process. In a thread is the segment of a process, means a process can be have multiple threads, and these multiple threads are contained within a process. A thread have three states: the running, ready, and blocked. Thread takes less time to terminate as compared to process, and like process, threads do not isolate. So here the difference between process and the thread. As you can see here, there are similarity. The difference between these two is in the process. As you can see here, process means any program is in executions, while in the thread means segment of progress. And here, the process takes takes more time to terminate. In the trade, this takes less time to terminate. So as you can see here, the trade is there are less time to use, and the process is more time to process. So in a tree, and number three, it takes more time for creation, and it takes less time for creation. So as you can see, the trade is very fast and efficient. Uh, so now this is the end of my video, and thank you for watching.